Hello, my name is Brian and I'm here to hack on some Tiger Beetle. So Tiger Beetle, it's a financial database, high performance, written in Zig. And we're doing a project on Stream to create a Rust client for that database. Tiger Beetle already has clients for a number of languages, including Java, Go, JavaScript, and Python. And now we're creating a Rust one. All these clients are actually wrappers around a single library called TB client that's written in Zig, and it exposes a C interface. In the future, we might write a pure Rust client for Tiger Beetle, but first iteration, we're just binding to the existing tested library. We've been doing this for about 2 months entirely on Stream. On Twitch. If you watch it the whole stream, front to back, the whole series, you'll see this entire project being constructed, every single bit. I think it's a pretty good project for showing, various Rusty production topics. It's got a lot of FFI. It's got a lot of unsafe stuff, issues of representation and unsafe representations and conversions. A lot of deployment issues, build system issues. Async IO, and doing async IO and managing the async IO lifetimes in the face of a bunch of unsafe bindings code. Pretty rusty stuff, I think. Recently, we have finished implementing all of the, 8 request types in Tiger Beetle. We spent a lot of time kind of exploring the design space. Like, we implemented one request at a time, and then we implemented, started with one request, kind of implemented it as best we understood, and then we went on to another request, copy pasted that code, and then implemented a second request, uncovered all the new information that we gained from a second request, because there are a few different kinds of requests in Tiger Beetle. And, as we implemented more and more requests, we uncovered new information and understanding about how these Rust APIs should look, and then kind of extracted generic internal abstractions in order to help us implement the requests. And it was very slow going at first as we learned and iterated. But then by the time we got to the last stream, we implemented several of the remaining requests very fast because we had kind of built up our internal abstractions very well, and it was just easy peasy at that point. So that was kind of at a big turning point right now where we need to kind of step back and evaluate what we need to get done in order to get a PR in. Our first PR is not going to be like the production ready PR, just some code to, show people progress, get more eyes on it, maybe get people trying it out. And so today we're probably just going to kind of regroup, look at some of the to-dos we've left behind, and kind of make a to-do list of future work to do. Hey, Cargo Moon, glad to see you in chat again. This has been a great stream series for me because a lot of people have showed up in chat and participated in helping debug on Stream. And it's been very useful because, especially on Stream, it's pretty hard to, think. And so having an extra set of eyes and minds has been very rewarding. And we've uncovered quite a lot of Rust knowledge on Stream together. All right, I'm gonna adjust my lighting real quick, I think. Give me 1 second here. There we go. That makes more sense. All right, so let's go get to the code and just kind of figure out where we are. It's been a few days, so I think I'm gonna kind of clean up our history and rebase and just kind of get everything reset again. And you'll see my history here is a mess because I don't really care about history at the moment, but we're getting to the point where we're gonna need to care about history. It's pretty likely that this initial PR is just going to be one commit that kind of summarizes 2 months of work. I used to, last time I talked about how my approach to unit testing has changed over my career, and my approach to commit structure has changed a lot too. Um, I still value having a clean commit history, and I like to have, sensible progression in commits. But I'm much less, sort of like I'm very less fine grained about my unit testing these days. I'm also much less incremental about my commit history. It used to be like every step of the way I would make a commit and keep it logical and clean. But these days I'm much more willing to have pretty big commits that do a big step all at once. Though it kind of depends on how gnarly the work is. Like if the work is like a big tough refactor, I might have much smaller steps. But this is kind of a big bang project. Like it's entirely self-contained. I haven't touched any of the Zig code in the Tiger Beetle repo. So almost certainly I'm going to submit one commit as the PR for this project. I'm just looking through our history right now, and I'm going to squash all this junk. I think I already copied this, but I'll go back and copy it again. I'm going to say just reset to this commit. And I'm going to back up to our top level repo and just recommit all this code. And you can see it's a pretty small set of files. In fact, we're going to do a line count on the whole Rust bindings and see what it's like. All right, so that's where we are right now. And then I'm going to fetch the upstream code and rebase onto it. This is the main branch. And rebasing this project has been very easy because, again, our code is very independent, but occasionally the underlying C API that we're binding to does change. So after we rebase, we need to go rebuild that library because I don't have the two build systems hooked up yet. So do clients:C is just the name of the rule in the Tiger Beetle build script. And that'll give us a C library, and then we can go to our Rust crate. It's in clients Rust and say cargo, we'll start from scratch, clean. And then do a cargo check and cargo build. And I suspect there'll be no problems here. We'll come back to this in a second and go kind of get our bearings in the source code. And hey, Cargo Man, I just thinking about you also come check out MatClad's stream every Thursday, and I also come and check out MatClad's stream usually almost every Thursday. I'm Burson_dev when I'm on Twitch, not as Tiger Beetle streaming. So I see you in MatClad's chat every week. All right, so let's see. I'm going to put like a to-do list up here in our library and kind of just review the code we've got and kind of figure out what our short-term roadmap to getting a PR in is. For now, what I'm going to do is actually I want to split this screen. I'm going to create a to-do list here and just note that I'm using these multi-line comments. I find multi-line comments very useful for this kind of stuff. A lot of languages, modern languages especially, are reluctant to provide multi-line comments, but I continue to love multi-line comments. What is this? Just real quick, I'm going to read this thing here and figure out what this note that I left to myself previously means. Need to provide filter limits. Okay. Yeah, so some of these filters, when you do a range query in Tiger Beetle, there's each type of range query has a number of results that it can return at once, and that's a hard-coded constant. And so we got to provide some way for users to deal with that. That's not super high priority, though. I'm going to put this other to do. We've got a low priority. I'll put this PR to do here. And I'm going to, on my right pane, I'm going to collect some to-dos, and then on the left pane, we're just going to kind of go through and look at our code and think a little bit about what is left to do. First, I'm going to go back to our terminal, and we see that it built successfully. I'll go ahead and run a server here and just run our little smoke test and see if it seems to basically be working. What am I doing wrong here? Oh, I ran the REPL, not the server. I want to run the start. That'll run the server. That's what is going on there. Look at that interesting info output when I ran the server. Get account balances. That's so interesting. I don't have any clients running, but it output these logs. That's so interesting. I wonder if those are like replaying failed queries from our previous debugging sessions, because this flags history equals false. And so we found out last stream that you can't query historic account balances if you don't tell it the server to record history for a particular account. That's so interesting. I wonder if we restart the server, if it will still replay those errors. I wonder what's going on there. Anyway, kind of irrelevant to what we're tasked with today. Let's go ahead and run this cargo run, just see if it does something interesting. Okay, looks like it's basically working. Now let's go look through the code. This allow unused, we got to get rid of that. Can't leave that in production code. And let's keep going down here. This is all probably normal stuff. So these flags here, gotta figure out something to do with these flags. These are bit flags. And right now we're just kind of exposing the underlying C constants for those flags. And just in this Rust API, just saying, here's a U32, I think, that is a bit field, and you figure out what to do with it as the user. But we can't just expose these constants. So we got to come up with something to do with bit fields. And it's a tough question. For the first PR, we're going to do something simple probably. We're probably just going to say, like, here's a field and here's some constants, kind of like we're already doing here, but we're not just going to re-export these hideous names. A little more rusty. Do something about bit fields. And then for the final API, we're going to have to do some research into what like the current best practices for Rust bit fields are, because there's trade-offs and no really satisfactory ergonomic way to do bit fields in Rust, sadly. This client, this is fine. Okay, so this constructor, there's things we haven't done with the constructor. This addresses, right now we're just passing in a string. I think that's probably fine. This is a string of multiple addresses that get parsed, but that address parsing is kind of common code across Tiger Beetle. It's probably okay to do that. We might also want this to be like typed, right? Like an array of, or a slice of IP addresses. That would make a lot of sense in Rust, but parsing a string is not terrible. This cluster ID, we are passing the cluster ID. Addresses, this is like a client custom data. And so far, we haven't actually found ourselves needing this. I think this is kind of like up to the clients to use it however they want for like relating client objects to request results and things like that, client objects to packets. But so far we haven't found ourselves needing it. We're relying a lot on closures in Rust to capture state like that, but it might be worth looking at the Go. One thing I want to do today is look at the Go bindings and kind of understand what kind of higher level niceties they're providing to Go users to kind of make sure we're on the right path here with the Rust bindings. But so far we haven't needed to use this thing. Probably should document this. Like, why are we doing that? Real quick, I want to figure out what the name of this field is and just write a little to do about it. So I'm going to look at my C definitions, and this is going to be TB client T, not TB client T, TB client init right here. On completion context, we're not doing anything with the completion context. So I'm going to say do something or document completion context. because I don't want to just submit a PR with this magic numbers right here. I put this magic number here just so I can see it. If it shows up in a log or something, that it would like flash warning signs. Like, that's a weird number. But right now we're not doing anything with it. Otherwise, this constructor all looks about correct. Oh, errors. So right now, the entire API is punting on errors. We're just using anyhow error type, which is basically just a universal, an existential error type. Like it gives you basically a string for an error with a little niceties wrapped around it. But for a client API, that's probably not good enough. We might need to go ahead before we do a PR and define real errors here, which is going to be kind of a slog. Define real error types. Define good error types. Better error types. But otherwise, the constructor looks fine. This is one of our methods. Besides the constructor, we have the destructor, and there's some to-dos with the destructor. But other than the constructor and the destructor, it's just these methods here for submitting requests. Everything else is just a request. And everything here looks fine, so far, except this result type is, again, just an anyhow result, where the errors are anyhow errors. And there's all kinds of potential error messages and error enums, error codes, I guess, that can be returned from here. And most of the error handling is in this collect results helper method. But also, yeah, just error handling in general. We're going to have to go over it and do something smarter here, maybe before we do a PR. But otherwise, this all looks okay. Now these are all very similar. Right here, we have a close method. So here's a drop method, and the drop just defers to close. But the reason we define a separate close method is so that you can have some kind of opportunity to handle a failure on close, and also so that you can wait on close. Because drop this is an async API, and this drop, you could make it blocking, but more likely you don't really want to block on close, block on a drop, because drop just happens implicitly. So having a blocking drop method in an async Rust application would be not that great. So here we have an asynchronous close method, and this drop implementation just calls the async close method and then forgets to wait on the future. So it does the close, but then just continues on, and closing will kind of happen asynchronously in the background. It's got to continue to happen safely, but we don't necessarily wait for all the cleanup to happen. And the reason to make this close method is so you can be sure that everything is actually closed and done successfully before you move on with the program. And so right now, this is not actually doing that. It's just calling client dinit and then continuing. But to my mind, what you want here is to just sit here and wait for some signal that all the work is actually done. And I actually haven't looked at what the underlying TB client dinit function does. Like, it could be blocking, though I would hope it's not blocking, because that's pretty limiting for the language bindings. So what I expect happens here is that this dinit function, schedules some work, like probably sets some atomic flag, like, oh gosh, the user is done, we got to clean up. And then a lot of the work in TB client actually happens on another thread. So then the other thread is probably going to be like, uh-oh, everything's being canceled. Let's clean up everything, stop submitting requests, and then call all the callbacks. Because the underlying library is a callback-based library. And so those callbacks, whenever a request is completed, either successfully or unsuccessfully, they call a function that we provide on some other thread. So what I expect happens is that you call this client dinit function, and then it returns immediately. And then on some other thread, you get callbacks saying, this work was all canceled, giving you an opportunity to clean up. So there's kind of a race here where you call dinit, and then we continue execution. And then on some other thread, all that cleanup is happening. And then here we have an opportunity where it's like, so we've got to wait for that cleanup to actually finish. We want to give the user the option. And that's all my assumption, though. I haven't actually looked at how this works. It could just block until everything's cleaned up. But I think I would like to, await this cleanup. Anyway, got a to-do. That's a big to-do. So we need to do await for close cleanup, I'll call that. And as far as the code goes, that's most of it. For now, here's one of those flags. Don't know what we're going to do with it. This timestamp I'm probably just going to leave as a U64 for now. I don't think the users are going to care too much about interpreting this. So I don't think we want to make it like a date type. But that's an option. We'll see how it goes through code review. These reserved fields, I'm kind of resolved right now to leave these reserved fields in place in the high-level API, because in general, Tiger Beetle leans toward exposing these details, these underlying details. Like again, the account type in the Surface API is the same account struct used internally in the database. Like that data type is not really translated as it goes through the layers of abstraction. What you see is what you get is when the data, as far as the data goes. I do know that somewhere, though, he had a field here, a reserved field, and I removed it from the Surface API because I thought there's no way we're going to force users to create this reserved set of, I think it was 58 bytes. It's like a 58 byte array. And that's actually hard to construct a 58 byte zeroed array in Rust. So I removed it from the API, and I want to reverse that decision. I no longer stand by that decision. Here's our 58 zeros. And I think this must be it right here. So account filter has a reserved field. And I'm just going to go add that back. Actually, no, I'm not going to add it back right now because it'll break the test code that we've already got working. I'm just going to add it to do. Restore account filter reserved field. And again, so in Rust, creating a large array of zeros is actually not trivial to do for technical reasons. So we got to come up with some way to do it, and somebody in chat suggested a way to do it last time by defining our own reserved type, and I think that's probably the best thing to do. Then we can provide a default implementation for reserved. And so one of my to-dos is going to be just to make it easy to construct reserved arrays. Where was that down here? I was just looking through these data types and seeing what else there is here that we have overlooked or punted on in the past. Okay, so these things, there's problems with how I've defined this API here. Let's go back and think about it real quick. This API is functional. Oh, sorry, I'm pushing multiple things onto the stack here at once. This API, let's not talk about the API yet, but Array API. First, some of these names are incorrect. There's a tension between like naming things exactly the way that Tiger Beetle State Machine names them and naming things the way that I feel makes sense for the Rust API. And I've kind of settled on naming these queries exactly how the state machine names them. And I know some of these are not quite in line with how the state machine calls them. Like create transfer, I think it's actually create transfers. So we need to go revisit that. Revisit naming of query methods. I think that's probably sufficient. All right, now let's go back and talk about these error APIs. And, let's look at maybe create account. Here's create account. And this returns a result of a vector of create account OK. This top level result is like potentially an error for the entire request. And every request contains multiple events, which are the actual requests. And each of those events has a response. And each one of those can also have some kind of failure individually. And the way I've represented this now is for each of these request types, I've defined what I have called a create account OK. And this naming is kind of no good. It's kind of mixed. It kind of mixes idioms in Rust. Because this looks very much like a Rust result type. But then if you look down here at account lookup OK, that's not quite like a Rust result type. And then again in here, so account lookup OK, like the only failure mode is a not found. These other ones, there are lots of ways to fail. Like you can look down here and see create account result. And there's just a big naming confusion here because this whole data type here looks like what is called a result in Rust. But it's not a result, it's my own custom data type. So you can conceptualize this as a result. You could actually make this a Rust result. And that might end up being what we do for idiomatic sake. But then inside this error variant of create account OK, which you can think of as create account result, and this would be an OK, and then this would be error. The inside of this is not called an error, it's called a result, which in Rust does not really make sense. I mean, you could have a result of a result where the error contains another result. That would make sense. But this result here is named after the underlying Tiger Beetle data type, which is called a create account result. But in Tiger Beetle API, this create account result also contains the OK or successful variant. So if we look at our create account result enum here, in the underlying API, there's also like a OK. And so we could also do that in Rust. Hey, Brongalus, good to see you here. We're just kind of like reviewing the state of where we are in this API design for the Rust client and kind of coming up with a to-do list of what we need to do to get a PR done. And so in the underlying Tiger Beetle API, there's a single data type called create account result. So when you create an account, you get a result. And it can either be OK or any of these errors. And so in Rust, we have this tension here where it's like, well, should we kind of like transform this result just a little bit to make it look more Rusty and wrap the, and create like a separate result type for the success, like a separate result type that encapsulates the notion of success and failure, in which case it's just kind of what we've done. In our API, in our Rust API, we've excluded that OK here and then punted the okayness, the successness, up to this data type, which looks like a Rust result, but isn't a Rust result. So there's a lot of tension here. And then as a result of that, we have this data type here, which in our API actually represents an error. But because this is kind of trying to mirror the underlying Tiger Beetle struct naming, it looks like a Rust result type, but it is not a Rust result type. So one thing we could do is just get rid of this create account OK type completely, add back OK here, and then just leave it like that. So the good thing about this, we would eliminate an entire level of indirection in our data definitions. We would just be returning create account result. For every, on the right-hand side here, for every event, you would get a create account result. And I don't want to type too much garbage here because I'm not going to be able to revert to our working build if I keep commenting stuff out. In fact, I've already deleted code that I don't need to delete yet. Let me checkpoint our commits right now before I continue down this path. Cargo check. All right, now I can type whatever I want. So one thing that could be nice to do is just get rid of this entire level of indirection and just return a create account. Oops, I think I screwed up and left this OK in there when I committed that. Create account OK. Yeah, just give me a second to clean up the mess I'm making here. Let's make sure that builds again. So, right, we could put an OK here, get rid of that other type completely. The downside of this, though, is it doesn't look, it's not idiomatic Rust. Then in order to interpret every single result, callers are going to have to basically match on this. And they could do something like, we could implement EQ here to let them match, just like, is the result equal to create account result OK, to determine if it was a successful query. But often, like, I don't have a lot of insight into how users are actually going to use this API, but often users don't care about all these details about different error types. They just want to know successness or errorness. And so I'm kind of reluctant to just re-expose this, because then they can't use all the niceties around Rust result types. And there's a lot of APIs around Rust results for doing convenient stuff. If I just gave them this data type, then they kind of have none of that. They have to do a match, and they have to handle all these things individually. So that's not really very Rusty. So it makes a lot of sense to me to have this level of indirection and exclude the OK variant from the underlying results. But then, of course, you have this naming problem. So maybe this wants to be a create account error. And then in the docs, you probably have to be like, this corresponds to the create account result enum in the underlying TB client API. Or maybe we don't even have to do that. I'm not really sure. But it's very nice for people working with a binding to be able to cross-reference the source of truth documentation. Like if they see create account result, they can go look at the main Tiger Beetle docs and understand what create account result really is versus what the Rust API says or doesn't say. So we might want this to be create account error. And I know I'm yak shaving a lot here. We're supposed to be collecting to-dos, but it's kind of a big question in my mind. And then this could just disappear completely, and this could become a result type. But then we have to think about this pattern here and how like account lookup OK looks a little different than a create transfer OK. We probably want to kind of normalize this in order to make all these results. Like we wouldn't want to turn just create account OK into a result and leave account lookup OK as kind of a custom data type. So for account lookup OK, we'd probably want to turn this into something like a result of account lookup error. But then this account lookup error does not have any relationship to any underlying Tiger Beetle structs. This would be fabricated in our API, and it would have exactly one variant, which is account lookup OK, account lookup error, not found. And then all these could disappear, and we'd have to just add this account lookup error type. All right, I'm kind of convinced myself that that is what we're going to do for this problem. And here, we already have something about revisiting define better error types. I'm going to say restructure, create account OK, etc. Or I'm going to say remove, create account OK, etc. types. Hopefully I'll remember what I meant by that when we come back to that in the future. And I've already made so many changes to this code. I'm going to go ahead and copy that to do, check out this commit, and then add that to do back again. And I think as far as the code goes, that is probably all we need to revisit. There's also issues about performance, but that's really, and there's also some maybe like helper APIs that we can build on top of this foundation. That's kind of not MVP material there. We'll come back to that in the future. The other big thing we need to do is we need to at least like start some test scaffolding and make some basic tests. We don't necessarily have to get them like airtight yet for an initial MVP, but submitting a PR without any test scaffolding, I think, would be irresponsible. We want some assurance that like the code does what it says it does. Create test harness. And that'll be a pretty good topic for stream. Okay, so I think that's kind of it. Now we can maybe actually start working on it on stream. I'm just going to take a second right here to catch my breath and think. Ooh. Lighting's looking good today. I want to get a like a wide angle second camera up in that corner so that when I'm just like pacing around the room, I can turn on the wide. You kind of like see a view of the whole studio here. I'm very into building out my music battle station. I use this studio for music too, not just streaming programming. I'm trying to make it as cozy as possible. All right, let's quit procrastinating and try to make a little progress on these to-dos. All right, I'm showing you my code again. Remove allow unused. Do we want to do that yet? Do I want to take the Band-Aid off yet? Probably. It's probably about time. Let's go see what unused stuff we have here. Check. And, oh, let me do a yak shave real quick here. Let me do a yak shave. So I do all my coding at the terminal. So I'm switching between my Emacs Tmux window and my compiler Tmux window, like this, Emacs, and here's the compiler. And for years and years and years, I just kind of use Tmux to scroll back in this buffer. But there's a lot of like fiddly key stuff to do this. And I'm getting kind of tired of it. Oh my gosh, look at all this stuff. Oh, we'll deal with that in a second. But anyway, I'm kind of sick of doing that back scroll deal. And so recently I've created a little alias for myself. Bash. And oh, wow. This is a little bash add-in file that I keep some extra niceties for my terminal, including my prompt is right here. And I forgot to bring it over to this computer, but I have a little alias that I've been using to deal with this problem, and I want it right now. I'm sick of doing the Tmux back scroll thing. And I think the way I did this is I called it lcargo for cargo less, and it's just a function. And unfortunately, I have to remember it out of my brain right now. And but basically what I want to do, I'll show you real quick. So here's cargo check. And you can see like the actual relevant information is screens away up here. And so the obvious thing to do is just pipe it through less. Huh. So I was going to show you the big problem with piping it through less is that cargo decides to not show you colors once you're piping. But that does not seem to be the case on this computer for whatever reason, which moots this whole point. I have an alias that I use on my other machine that just makes this just work and show the colors correctly. But it takes some stuff that I'm always forgetting. You have to do this. But on this computer, for whatever reason, maybe it's the Rust toolchain has gotten smarter, or maybe it's something about this WSL terminal. I can just pipe it through less and I still get colors. Oh, this is not actually right. This is still not right because, okay, scratch all that. Let's start over. You can see we're not seeing the back scroll here. We're seeing a bunch of colors, but that's because all that stuff is stood error. And what we're paging through less here is stood out. So to make this actually work, all right, this is so tough. You got to remember to do this thing, which is the magic bash incantation for piping standard error, which is 2 standard out. Have a good one, Cargo Moon. Have a nice nap. And I always forget this syntax. It's just random symbols almost to me. And I kind of always have to look it up. But this says, take standard IO handle number 2, which is standard error, and redirect it. I don't even understand what this ampersand even means, to standard out. And then you can pipe that through less, and then you lose the colors because Cargo says I'm not piping to an interactive shell, so I'm not going to try to show you all these control ANSI control codes. So to get the color back, you have to say color equals always, and then you get the ANSI control codes, but less does not interpret them by default. So then you have to tell less to interpret the ANSI. And now you have colors and they're piped. So finally, this is the first warning on the screen here. And this is just such a mouthful that I hate it. So let's go ahead and define a little alias. Or not an alias, but a function in bash called lcargo. And basically we just have to do this. And I think the best way to do this is probably to say cargo, and then we pass the arguments using some magic thing in bash. I think it's $ampersand. This is super magic. It says take all of the arguments to lcargo and splat them out right here. And I think it preserves spaces correctly, I think. And then we can say color equals always, and I believe color equals always will apply to every cargo command, but I'm not sure. There's also an environment variable. So here you could say like cargo color equals always, but I don't remember the name of that environment variable. Like one way this color always flag could fail is even if all of cargo's built-in subcommands support color equals always, Cargo has pluggable subcommands, so maybe those third-party cargo commands wouldn't support color equals always. Anyway, for now, this should work for our purposes. And now we pipe this with the correct syntax to less R, and that should be what we need to do this. So now I need to source that bash profile extras, which is again my own little add-ins for bash. Now I'm going to say lcargo check. There we go. Great. Yak shave complete. Okay, so pop in the stack again. We just removed the allow unused attribute from this library, preparing it for a PR in the somewhat distant future still, I think. And here's all the unused stuff. You can see anything in lib.rs matters because we got to go. Lib.rs is our own handwritten code and it's got to be clean. But I suspect there's some other stuff here. So this TB client RS is generated code from BindGen. And I thought I had already put the correct attributes on here, but maybe I was already relying on the top level allow unused. Yeah. So here we're kind of importing that generated Rust code, and it's already got all this stuff on it to make it not trigger lints because it looks gross. Then we're going to add an allow unused here, and that should cut down on our errors considerably. You can see we had 15 warnings. Now, if we add that attribute to remove the warnings from the generated code, we should have 15 warnings still. Well, I don't get that, but I don't understand why it still says 15 warnings. Maybe because let's back up, remove this again. I might have just done things out of order. Yeah, there we go. 107 warnings. So that one attribute cut down the warnings to 15. Now these are the warnings that we actually have to deal with because these are in our own handwritten code. So let's deal. Line 26, sender and cancel are not used here. 26. Line 94, next event is not used in that particular closure. And that looks okay. Event index. Yeah, okay. This closure is reused across all of our requests, and sometimes you don't need all the arguments to the closure. Line 77, we have some mutable thing that we don't need. Packet does not need to be mutable. What is packet used for? Packet. We're just moving it right into that box. Okay, let's just find all the mute packets and deal with them at once. And start over again. Here's another closure that's not using that next event. After we get rid of all these, what is that? Oh, you probably can't see that. I just had a window pop up. So this next event is not used here either. Let's hopefully we're not going to comment out all those next events. Then in 154, event index is not used. And again, in Rust, you can just prefix a variable with an underscore and it'll indicate to the compiler that we're not using that variable intentionally. Event index, unused variable event index 154, same thing on 184. And then here, completion method has fields that are not used. Interesting. This is interesting because completion message, this is just, I'm kind of thinking right now, like whether I like it that these are unused or whether we should actually get rid of them. So 3 fields here are not used, context, client, and timestamp. So let's go look at struct completion message. And then the reason these exist, all these fields that are not used, is because this completion message is used to smuggle all the arguments from the completion callback back to our original thread. So we just kind of blindly defined completion message the same way as this on completion callback is defined. And I kind of like that symmetry. Like I like that completion message is essentially the same as on completion. Like even though right now we don't use these contexts, I kind of feel like it aids in the comprehension here to understand that this thing is just kind of taking all those arguments and copying them back to the main thread. So and this is an internal type. It doesn't really matter if it looks ugly. So I think I'm just going to take these fields and keep them. It's not going to be like a big performance hit to copy a few words around when we're dealing with the context switches of sending between threads. I think I'm going to keep these fields just for the documentation that they add. And then here we need to call back. We need to do something with these fields. Somewhere they're constructed, so the names have to change. Where are these constructed? In this callback method, which is probably up in here, handle message. Well, I don't know where this completion message is constructed. On completion. Completion message. There's a channel of completion messages. Ah, right here. Okay, so right here, we're using this shortcut syntax for constructing these fields to completion message. Like here, the local variable context is being copied into the field context, and this will stop working once we've renamed context to underscore context. So we can say underscore context equals context, underscore client equals client, and underscore timestamp equals timestamp. And let's go start our build over, and yeah, we've introduced new bugs. So line, yeah, all that stuff I just wrote, the wrong syntax. That's a pretty perpetual mistake for me, is using equals during the whatever, the constructor syntax for structs. All right, there's only one more warning remaining. So here's an unused result. That's a good warning to look at. Line, I think that was just the same code we were just looking at. Line 552. Yep, exactly, right here. It's possible this send will fail, and we have not accounted for that. It's okay if this send fails. That means the main thread disappeared. And we have structured this code to account for that already. We just need to kind of indicate syntactically that, yeah, we've thought about what happens if this message doesn't actually send. All of these allocations will immediately free over here, which is, interesting to think about. So we've talked about this several times on stream, but this callback here happens on another thread, some other random thread, not a random thread, but some other thread that is not related to the main thread in Rust. And we're taking all these unsafe pointers and taking ownership of them here by putting them into vex and into boxes so that the Rust will free them. Once like if there's a panic, we need them to be freed by Rust automatically. And normally we expect all of these values to be freed back on the main thread because we're sending them back to the main thread. And so that's kind of like the normal flow, that somewhere on the main thread, a drop will be called on this vec and on this box. But in this rare case where the main thread disappears and doesn't wait to see these messages, then these will be freed on this other thread. And in this case, all these destructors are just deallocating using the global deallocator. So there's not really any considerations there about correctness. But if these are more complicated type with, drop implementations that did other stuff or were side effecty, you might have to think a little bit about well, what happens in the rare case that all these destructors run on the wrong thread? Just something to, think about as you're writing this kind of code. Anyway, that should all compile now. I think we've gotten rid of our warnings. Yep. And I'm just going to commit that. And actually, we can knock one of our to-dos down. See, is there another one we can do here? Bit fields. Do I want to deal with bit fields now? This completion context constant is easier to deal with. So let's go ahead and knock out easy things. And here I'm going to call this completion context. And then up here, I'm just going to define it. I'm going to say struct, nope, const completion context. And I'm assuming that's a U128, but it might not be. The compiler will tell us. Equals, and I'll just keep using the same constant. And then here I'm going to say the TB client completion context is unused by this API, by the Rust bindings. This is just a magic number to jump out of logs. And during review, maybe someone will tell us like, oh my gosh, you didn't use the completion context. Did you not understand this API? So hopefully someone will tell us if there's something we overlooked here that makes us have a use for the completion context. And this should probably be enough to get rid of that to do. So let's go ahead and run check again. And of course I did something wrong. The completion context is a usize. Again, I speculate that the completion context is just some datum that you're allowed to use for your own purposes to relate for like packets to clients on the language binding side. And then we haven't needed to use it. We've got other mechanisms we've used for that, like closure captures. Okay, so that looks like that one more off the list. We're making progress. The error types. I don't know if I want to tackle those first. This account filter reserved field. Let's deal with reserved right now. I think that's something that does relatively simple and somewhat interesting from a Rust perspective. So again, let's go to our conversions.rs. And this reserved here, I took this out of the Surface Rust API and I regret it. So this account filter is supposed to have a reserved field right here. Let's look at probably just like this, but with a different size. This is just like explicitly sized padding bytes to make this struct exactly a known size with no implicit padding bytes, and also to save some size for future use. So save some bits in the struct for future use. So this is going to be 58 zeros. And here we can just, in this conversion function, you say other reserved. And now we don't need this 58 zeros constant anymore, but this is going to break our main smoke test. So if we check, you can see our main function is missing reserved. And if we try to construct that reserved using normal Rust mechanisms, it's not going to work. I'll just go do that real quick. So account filter, where did that go? After code is reserved. And the way we normally want to do this is by saying default to default. I really wish there was a function called default in the Rust prelude, so you didn't have to do this common duplication. And this is not going to work probably. I think there's another account filter somewhere up here. Yeah, right here. Because default isn't defined for such large arrays. And you can see right here, not implemented for that big old array. And it's just a limitation of Rust's type system. This limitation is, if it's not lifted today, it's close to being lifted. Like maybe the next edition of Rust will define this universally for all possible arrays. Maybe they're just waiting for another edition so they can make a breaking API change there. I'm not sure. But we can't just do that. And so what I think, let's see, is there any way we can make default work? Like we could try to define our own implementation of default for that array, but we're not allowed to because of the trait coherency rules. So what I think we want to do, as suggested in, and there might be a Rust crate for this, but I don't think we want to pull in a Rust crate just to do this one pattern that we're going to do. But here somewhere, let's do it down here. We're going to find a little helper struct called reserved. And we're going to make it probably same attributes as all these things. And it's going to call it pub struct reserved. And this is going to contain an array, but an array of arbitrary size. And we used numeric generics in Rust for this, which I have not used a lot, and I might get the syntax wrong. There's a constant usize. So this is just a number that is generic. And here we put an array of u8 in, like that. And we'll probably make that pub, so if the user needs to access it, they can, though. Why would they access those? No, don't need that. So just like that, that's our definition. And now we can define default on that. But also, we probably want to just say that this reserve type is not actually a struct, but uses the same representation as the underlying array. Just for the future, there's a good chance we're going to be bit casting these structs to the underlying C structs, and we will need them to have the exact same representation. In which case we would need to do this per transparent, which would tell the C compiler to pretend this is not laid out like a struct, pretend it's laid out like the one thing, the one field of the struct. But I don't know if I actually want to do this right now, because right now we're not defining these as the same representation as the underlying C types. So if we did represent transparent here, it's not serving any function right now. And yeah, so probably want to say just like that and not try to define the representation. But now we can say impl default for reserved, impl in, and this might need to say const in usize again. I'm not sure. Again, I've not done these numeric generics, whatever. I don't remember the exact term, numeric generics in Rust very much. Default for reserved in something like that. Hopefully the compiler will tell us what we got wrong there. And default has one method called default with no arguments that returns a reserved in. And now we actually have to write the code that is able to do that. And I have to think about, like, well, actually, do I know how to write that code? I'm not sure I actually know how to write that code. We talked about this in stream a few days ago, like how, well, this is like the right shape of the API, but I don't know if I know how to do this in a way that is idiomatic. Like we could create a array here filled with uninitialized and then initialize all the elements in a loop and then return that array. This is something that I've never actually done. Actually, this is super easy, I think. This is super easy. And in fact, we might not even do reserve because there is a way to initialize this array. Rust does have a syntax that'll work here. We can say this is an array of 0 repeated n times. And users could do that themselves if they wanted to. They could write that like 0, 58 if they really wanted to. So still very inconvenient for a user to understand how to initialize that array. But this should actually work. I think this syntax in Rust will duplicate this 0 n times. So that should work. But those details are maybe not all correct here, and let's see what the compiler thinks about it. Oh, wow, did I actually? The compiler is not complaining at all about what I wrote here. I'm very skeptical. I felt like some of that must be wrong. I kind of guessed at a lot of this. Wow, I guessed good, I guess. I guessed good. So now then, this is public, and it implements default. So if we go to our main function again, here, oh, we have to actually use this reserved in our reserved fields. So this is going to be a reserved of, shoot, I just didn't look at that number, 6. Reserved of 6. And then up here, there's going to be another reserved. This is a reserved of 58. And maybe MatClad will review this and tell me if there's a smarter pattern that's supported directly on STUD without defining this reserved struct. Let's see if there's any more reserved. Here's a 56. Reserved of 56. And I think that's all of them. Okay, there's 3 reserved fields here. And now that we've changed this type, our conversions over here are going to break, but should not be too big of a deal. Reserved. So here we're creating a count from the C type. So we should be able to say, and we're going to say, what are we importing here? Okay, this module is importing everything. This is a conversion. This module here is called conversions.rs. And it just contains impls of from, because these are really ugly and don't want to pollute the readability of the other modules. So let's again go to reserved. Here, this is creating an account, so we just wrap this in a reserved. And I am already regretting making this public. I don't think callers need to know what's inside of a reserved. So that should work there. And then here we're going the opposite direction. So here we just take the field out of the reserved. There should be one more here. So here we're creating the Rust account filter from the C account filter. So we just wrap the array in a reserved. Oh, here's more. TB account balance. Here we're creating a C type from the Rust type, so we just unwrap it. Here we're creating a Rust type from the C type, so we wrap it. And that's all of them. Now the library should build, but the main function won't build. And I already know that reserved 0. Account reserved 0. That's the wrong type completely. This is TB, I'm going to say default. I really hate that stuttering right there, that default. Let's do the other one down here the same way. But it's idiomatic, and Rust users will know that I can just call default. Okay, so stuff is wrong. And again, we can use our lcargo alias to go back up to the top here. Line 52 of conversions. Let me pull it over to my other window here. Oops. Uh-oh. Suddenly I've forgotten my fingers how to do the go to line in Emacs. This happens pretty regularly, that all of a sudden my fingers will just forget one of their things. Huh? Oh my gosh. Nope, that's not it. Go to line. What line was I going to? Maybe Emacs will tell me what the key combo was. Nope. Let's see if apropos will figure it out. Go to line. Go to line. Alt-GG. Is that not what I was doing? That is so unsettling when that happens. Like that, go to line, Alt-GG. I type that, I don't know, dozens of times a day, and I have for a decade or more, and it just evaporated out of my brain. Like, that's unsettling. That is unsettling. All right, something's wrong here. Tuple struct defined here. Mismatched types. Arguments to this struct. Expected a UA of something, found a U32. Maybe this, maybe an account. This is not actually a array. Let's go look at, let's go look at the underlying Rust definitions, C definitions. TB account T. Reserved is defined as a U32 right here. Well, this raises a new question. Like in this case, for consistency in the REST API, I hate to have a field called reserved where sometimes it is a reserved wrapper and sometimes it's a U32. Let's try to keep this reserved wrapper and do the conversion from the interior bytes of the wrapper to the U32, because I value that consistency in the REST API. If we're going to have a type dedicated to reserved fields, I want all the reserved fields to use the reserved type. All right, so in this case, we need to create a what was this? A U8 of something. Let's go back over to our library and look at that struct account. Oh, interesting. So I left this as a U32, but I don't want to do that. How many bytes are in a 32-bit integer? I'm going to say 4 offhand. That sounds right. This is a reserved of 4. Scary that I just don't just know that. I generally remember that 64-bit ints are 8 bytes, and I can work from there. Right, so this reserved, this is still not going to work because it's the wrong type. Here it's a U32, but we need 4 bytes. But I think you can just type into here. And then here's the opposite direction where we're converting this array of bytes to a U32. I don't know if into is going to work here because of Indianness. I think we might need to explicitly tell it what Indianness we want this thing in. So let's say 2, which way are we going here? 2 bytes, little Indian. Yeah, let's try that. And then down here, I'm going to say from bytes, little Indian, U32. I'm assuming this function exists. I'm not entirely sure. From bytes, LE. Again, the Indianness doesn't matter here because it's all zeros, but we need to be consistent because we need to work with one of these conversion functions that expects Indianness. And there's lots and lots of ways to convert between arrays and numbers and bytes in Rust. I'm always forgetting which ones to use in which scenario. Let's go see if this builds. I mean, it doesn't build, but method not found for U32, 2 bytes LE. That, I don't believe you. All right, we're going to have to go to the API docs. There's an associated from big Indian. Maybe it's just a 2LE then. From bytes LE, it's not found, but it's from BE, it does exist. So we can probably say from LE, let's just see, from LE, and it doesn't sound familiar. None of this sounds familiar. Expected a U8 of 4, found a U32. Oh, okay, so these 2 LE, these are maybe just doing some byte swapping, what's the swizzling or something like that. To switch around the order of bytes from the native order to the specified Indianness. So that's not what I want. Let's go look at some docs. I'm just kind of shocked I don't remember how to do this. We've dealt with the same issue on stream before, just recently. Real quick, sometimes it's as simple as just writing into. Real quick, Let's make sure there isn't some conversion trait that just works here. Yeah. It's not going to implement this by default because there's Indianness questions. Okay, let's go to the docs and figure it out. Stud. Oh, only recently I learned that you could go to stud.rs and it'll just redirect you to the standard library docs for Rust. I've only learned of that recently. So let's look for bytes LE and see if that comes up with something. Maybe I'm just getting the word order wrong here. It's LE bytes. Okay, there we go. So I just guessed kind of the wrong order of the words in these method names. So there's a 2 LE bytes on all the integers. Let's see if there's a from LE bytes. Yep, exactly. That's easy enough. All right, going back to the code, remembering to switch OBS scenes. All right, these N2s were not the right thing. The right thing was more or less what I wrote before, but this is 2 LE bytes. And down here, this is a U32 from LE bytes. And that, I think, got us past those errors. Let's go to line 209 to the next one. And I've gone in the opposite order here. Here we're going from the Rust type to the C type. So I've just done this backwards. Presumably this one down here. Count filter. Oh. Let's look at the other ones. I bet there's some other ones that are wrong. This is going from, yeah, this one's backwards too. All right, let's see what the compiler says now. One more. 1226. This is going, yeah, I did all these backwards. Reserved. There we go. Okay, so that, hey, oh, and all type checks. Let's go ahead and run our smoke test and just make sure it seems to still be doing something. All right, looks like it's doing something. And actually, real quick, I want to go enable some, we have a lot of disabled functions here. Future Highway, can you say a little bit more about why maybe uninit would be better there? I actually don't know a whole lot about maybe uninit. It was only introduced, well, several years ago now, to handle issues of initialization where some of your fields are initially uninitialized and you have to, wait for some span of lifetime, some region before you can actually initialize the values. Like a maybe uninit type in Rust allows you to safely express that, this memory slot is not actually initialized yet. And in chat, Future Highway is suggesting that this ad hoc reserved type might be better served by a maybe uninit type. I guess if it's maybe uninit, you could probably just say like, give me a maybe uninit and put it in this field. And then maybe the API around maybe uninit won't allow you to touch what's inside of it without initializing it. Though I would be reluctant to pass an uninitialized field to the C API in case they're touching it for some reason, because you're just undefined behavior as soon as you touch that uninitialized memory, even if it's in some other language. But we could go look at I've never really closely looked at the maybe uninit type. We could go look at it on stream and see if it makes sense to use there. Though I would also kind of suspect that, like, if the default implementation for large byte arrays is not defined by the standard library. Maybe uninit is also not defined for those large byte arrays. I'm kind of curious about maybe uninit now. But real quick, let's just checkpoint what we've got here. All right, nothing here is panicking. That's all I really care about. All those functions are doing something. Yeah, let's go look at maybe uninit. Let's go back to the web. Maybe uninit. So you have a maybe uninit of t, and maybe uninit itself is safe, but you can't do much with it. So wrapper type for constructing uninitialized t's. Probably initialized. So the compiler assumes that variables are initialized, but maybe uninit allows you to get around that. And it used to be you had to be like very careful when doing this. You would say, I think there's an intrinsic macro that says, give me something that's uninitialized, and it was super unsafe, and maybe it was not even sound. I don't remember. And so this type was provided to create uninitialized values. Variable of reference types. Oh, there's a lot to read here. I don't know if I'm going to read all this on stream. Allow unsafe code to deal with uninitialized data. Might not be initialized. Out pointers, okay. Initialize. So this is what I was suggesting before when we were talking about constructing those arrays of arbitrary size. I was thinking, maybe we construct an uninitialized array and then iterate and construct the array in place after it's already been initialized to uninitialized. But we didn't need to do that because there was a syntax we found that could initialize arbitrary sized arrays. But like if you didn't have, this example is exactly what we were talking about before. So here's an array of, interesting, I don't actually know this syntax at all, but here's an array of some type of thing, and they're setting them to uninitialized, where we used this exact syntax ourselves, and we said, we put a 0 here. That's all we had to do. But with maybe uninit, you could put any arbitrary value right here and initialize 1,000 of them to maybe uninit. Initializing a struct field by field. Yep, makes sense. Yeah, I think I know you're saying stuff to me, Future Highway. I'll come back to you in 1 second here. But my impression here is it wouldn't really make sense to use this in the public API. That's kind of a lot to expose. Like, it's really just we want zeros. It's not that we want like these fields to actually be uninitialized. We just want them to be zeros. And in fact, the underlying TB client is going to check those and make sure we've upheld the invariant, that we haven't tried to use those reserved fields for anything. It's going to read them and check them for zeros. So we don't literally want these to be uninitialized fields. No, Future Highway, thank you very much for suggesting that. It's really good to go like dig into these subjects on stream. Like this is a very important type in Rust these days. And Rust programmers should understand it, and it's telling that I don't really understand it. But basically, yeah, if you have something you need to initialize, but you don't have a way to initialize it all through a single constructor, you can create a maybe uninitialized version and then piecewise build the type. And it's interesting that maybe I've used this type, but I've rarely actually had to use this type myself. And I've done a fair bit of unsafe Rust programming, especially FFI programming recently. But like the docs say, there's a bunch of very typical use cases: out pointers, array construction for non-primitive types. Like we're constructing an array of primitive types, and we found that Rust has a built-in syntax that works fine there. And this, I've never done something like this, like where you access the fields of a struct unsafely and just build up the fields of a struct in Rust. Never done that in Rust. Anyway, I think we explored that enough. I still think the reserved struct makes sense here. But there might be crates that also handle this exact pattern in a way that makes sense. And okay, let's pop the stack a few levels here, go back to our to-do list, and I think we have resolved this reserved field issue completely. Yes, okay, let's checkpoint our work. All right, bit fields, error types. This await for close cleanup is an interesting subject, but I might save it for an entire stream. Again, we talked about this earlier today, that I want the close function to allow you to completely wait until everything is definitely cleaned up on other threads. And we're going to have to do some investigative programming here, exploratory programming, to see what the TB client actually does when you close it. I have to do some investigation there, and it's going to be a pretty chunky piece of work that I think we'll save for an entire stream. Test harness, we definitely going to save for multiple streams. That's going to take time. Naming of query methods is easy. Let's knock that out. So let's go to the state machine. And I believe all our types in Rust are defined correctly, with the correct names at least. Let me give some more space here. I'm very picky about spacing. These flags, we just talked about flags. We got to redefine those. All right, let's look at our query functions and go to, all right, here's our reference for our request names. Submit create account. Create account. So this is plural. And then create transfers. Get rid of this to do. Create transfers. Create transfer, okay. Singular transfer, but you have multiple of them. And I think those are probably the only two I have wrong. Submit account look up. Oh, that's wrong. Look up accounts. Look up accounts. Yeah. These first few methods date from like the very first few streams we did. And we've learned a lot since then. Look up accounts. And this struct is named backwards from what we just renamed the method to. What is an account lookup? Okay, let's jump down to account lookup. Okay. Lookup account. Okay. Account lookup. Okay. Lookup account. Okay. I think this is probably backwards too. Let's do this lookup. I was wondering whether this account lookup name corresponded to a struct within Tiger Beetle, but I don't think so. This is completely made up by us for this API. Account. Oh, account lookup. We're going to have to change the place where this is used to. This is going to be look up account. Look up account. Look. I just kind of like stopped mid-thought when I was renaming this method. This is look up accounts. And this is going to be look up account. Again, this is plural in the method because we're looking up multiple, but then the individual results are singular. Look up, this is the result for one account. This is endless source of confusion and frustration for me. It just kind of like tickles my brain the wrong way, seeing that singular and then plural, or plural and singular, even though it makes sense. It makes sense. All right, look up accounts. Look up transfer. Transfer, look up transfers. And then this is going to be look up transfer. And transfer, look up transfer. lookup transfer. This is going to be lookup transfer. And go through our other methods. Lookup accounts, lookup transfers, get account transfers. And I think at this point we got our naming figured out, and these are all the same. Query transfers. Right. Get account transfers, get account balances, query accounts, query account balance, query. I've ordered these methods incorrectly. I'm looking for query accounts, and I'm seeing query transfers. Yeah, I put these in the wrong order. In general, I've said this multiple times on stream before, but I want the Rust definitions to be in the same order as the Tiger Beetle definitions. There's query accounts, there's query transfers. All right, I think that's everything. Of course, our main function is going to be very wrong now. But let's just have the compiler tell us where it's wrong. And let's do a cargo check, and we'll do an L cargo check again. Line 34. This is a create accounts. Line 72. This is submit lookup accounts. Line 89 is create transfers. And then line 113 is submit lookup transfers. Is that everything? That's everything, okay. And commit that. And also we can remove that to do. And I'm gonna push. I'm gonna take a step. What is this? Oh yeah, force push. And just take another quick breather. We made some good progress today. I have to decide whether we're going to keep going and do something with the error types here. Kind of feeling toast. I'm not sure. Let's go look and see what's up there. Let's go see what's up. Give me one second, just 1 second. Yeah, just 1 second. Whew. Yeah, let's go look at the error situation again. See if we can make a little progress there. Bit fields, error types, remove the create account OK types. Remove the create account. I want to add one more thing here and see. There might be like some types of errors where, I don't know if I actually want to do this or not, but there might be some types of errors where it makes sense for the bindings themselves to take some action and not just pass the errors all the way back. Like we might want to assert some things, like we make some errors impossible and assert that those errors never happen, that kind of thing. Like about limits, like we can prevent the user from submitting too many events at once, perhaps. But I feel like that's maybe out of scope for now. But in the future, we might want to actually like look closely at what all the possible error codes are and see if there's anything we should be doing and not passing those error codes straight back to the user. But I think that's kind of a far future concern at this point. Let's go to our library and our error types. And let's again talk about that issue of the design of these errors. Let's just try to sort it out. Earlier I said I was kind of decided about how to deal with these. Are these the only 3 custom error types we've defined? Oh, there's another one down here. Okay. Why is this one way down here? Lookup transfer, okay. Lookup account, okay. Yeah, these are not in the right order. This doesn't make any sense to me. Are there more down here? No. All right, so we got this helper type here. I'm gonna get it out of the way, make some visual space, because these are different types of things here. Yeah, this feels like it's in the wrong spot. Let's take this and put it up here. Nope, not there. It's still the wrong spot. Here. So all of these 4 types are types that I conjured out of my own brain. They're not mirroring some underlying type in the Tiger Beetle API. And these are basic data types, fundamental Tiger Beetle data types that are just mirrored. And then here are error types. And then down here, there's data types again. Is this the only error type? Oh, there's 2 error types: create accounts, create transfers. Huh. There's no other error enums here? I guess not. Anyway, I'm still feeling these are kind of out of order. These structs I want to put up with the other structs. It also kind of makes sense to put these error types near the structs that they're related to. But a lot of these structs do like double or triple duty. They're used in multiple request types. So at the moment, I'm feeling like I want them all to be near each other. Like all the data types to be next to each other, all the error types to be next to each other. Again, while keeping them kind of ordered in the same order as the underlying Tiger Beetle code. So these I'm all pretty happy with right now. These I'm very unhappy with. I think these are I'm happy with, except that, so these error types, right now they're incorrectly named. Right now they're called result, but I want to rename them to error, which is going to be a little confusing because the Tiger Beetle types are named result, but that doesn't really make sense in the Rust API. So let's do like one quick thing at a time. So here's the plan here. We're going to do a refactor. It's going to be a several step refactor. First thing we're going to do is going to take these things. All right, what we want to do, the end result here, is that we want these to not exist. We want to reuse the Rust result type because the shape of all these 4 types is very similar to a Rust result. And so we want to make these into Rust results so that the users can get the benefits of all the APIs around results. And you can see they don't all quite look the same, but we can kind of fit them all into the result mold pretty easily, I think. Just that'll allow us to just completely get rid of all these types. And then within these types, some of them that actually have possible errors, these create accounts okay and create transfer okay, the result types is going to contain a create transfer error, not a create transfer result. So it's basically 2 steps here. We're going to make these not name result, we're going to name the errors, and then we're going to make all these types disappear. So let's do the easy thing first. Just rename these to error. And then up here, these are also mentioned right here. And I'm guessing there's conversions in the conversion module for these. Let's go to our conversions module. All right, here's one. And again, the order of definitions in this conversion module, I'm kind of comparing this to the order of those structs that I just reordered. And I'm kind of not loving how these are ordered. They're kind of ordered in whatever order I had to write them. And it would make sense to get them in the exact same order as the declarations and the library module. Although this module, again, is just a bunch of boilerplate and doesn't matter very much. But for the sake of aesthetics, I will probably reorder these. But one thing at a time. Right now we're renaming this to error. And you can see here, we've created this little impedance mismatch, which I don't know. Now that I'm seeing this again, I'm kind of doubting myself all over. Like for these particular two types, the Rust type is going to have a different name than the seed type. And in practice, like when users are using these bindings, they're probably going to be looking at both the Rust docs and the Tiger Beetle docs. I don't know. I'm doubting myself about this completely. Doubting myself about this. Let's go back real quick. So if we turn these into result types, then it'll be an error of create account result. A result of create account result. It's kind of a mouthful and confusing from a Rust API perspective, but it's consistent with the Tiger Beetle API. I'm doubting myself, chat. Very much doubting myself. I kind of want to undo this and punt this whole topic because I'm thinking maybe I made the wrong decision just now. Let's see. Let's save everything and look at the state of our workspace here. Ugh, and I did multiple things at once. Great. Yeah, let's back up. Let's just back up these changes. This, I want to leave these as result for now. Check what we're doing. Checkpoint. Always do one thing at a time with your commits. And now I want to go over here and do the other little bit of yak shaving that I was just talking about with the order of these things. So first I want to do the basic data structures, and then I want to do the result variants, enums. And this will make me feel a little better to have these in some aesthetically pleasing order. Okay, if we go back to our definition up here, we have account, then transfers. Yep, account, then transfer, then account filter, then account balance, then query filter. Okay, these conversion methods are all in the same order now. Okay, feeling good about all that. Let's check that, commit our work, and then go back and rethink again what we're doing with these errors. So again, unconvinced right now about whether to rename create account result to something else. I am convinced still that these types should not exist, so let's get rid of them probably one at a time. So let's go see where create account OK is used. Just one method. These basically correspond to a single method. And so now I'm doing a little bit of work over on both panes at the same time. So on the right-hand side, I make sure you can see it in the my face over it. This create account OK we don't want to exist. This is going. Let's see how big of a mouthful this type signature is now. This is getting pretty ugly. It's going to be a regular old result of nothing or create account result. And did I match the number of pointy braces? 1, 2, 3, 4. 1, 2, 3, 4. Yeah. So that is a pretty nasty type signature right there. Not totally unusual. Like you have a result for the entire collection, the entire vector, then individual results for the individual results. And this nil type for the OK case is idiomatic. So in our previous API, the one we're about to replace, we did have the word success there, which is nice. But here, this is just an OK of that, right? Which is fine. And I think ultimately this is more idiomatic, though that is really, I mean, for experienced Rust developers, this is readable. Like this is something you see fairly often, but it's a lot. Anyway, let's do it one method at a time. So I think we can go down here, and this is only going to matter once we get way down to here, and it is going to impact this collect results. Let's see if we can do this without rewriting collect results. But to do this, probably got to look at the implementation of collect results. And again, we haven't seen this in a few streams, but this is a intimidating function. Look at all that. But I'm curious about what the types are for these two arguments here that represent our two success and error variants. So the empty result is some sentinel type, and the non-empty result, okay, gotcha. So in all these collect results cases, there is, I guess I should recontextualize this. The way the underlying protocol works is when you're doing these queries of multiple events at once, the protocol likes to prioritize having some empty result, giving some empty result a meaning. So it will try to save space over the network by not returning results, and you have to interpret what that means in each individual query type. So this collect result says, like, what if we don't get a result for a particular event? What does that mean? And so there's this kind of like copyable sentinel value that means like this is the empty result. And so here in the create account OK, it just means success. So for us, this is probably going to mean Rust result wrapper. This is probably going to be a result type of this Rust result wrapper is probably exactly that Rust result type we just wrote out in the method signature. So this is going to be a OK of nil, I believe. And then here, if we do get a result, then this function is like, give me some closure I can call. Well, not a closure, but a higher order function I can call. And so this is going to be, look at those extra spaces there. This is going to be an error of create account Rust result. Gives me a Rust result. I think this is an error of, I think it might just be that. So in Rust, error variants are also higher order functions. This error is a function. That was a close one. I just sneezed. For those who are listening and not paying attention, or not, sorry, don't want to accuse you of not paying attention to me. Listening and not watching, I just had a major sneeze. I had to mute real quick. Major sneeze. I think this smells right to me. I'm not entirely sure. I'm going to go ahead and go find that previous type that we are getting rid of. What is it called? Create account OK. Should not be using that anymore. Let's see if this builds. Check. It builds. It does build. That's very suspicious. Did I actually type all that correctly and think through all those changes correctly? I'm so suspicious. Huh. I guess I did it. It's really rewarding when your brain works the same way as the Rust compiler works, because the Rust compiler is, very deep in its thinking. And so when I can actually think through all of the implications of the code I'm writing as far as the Rust compiler, and I don't get compiler errors, like I fully expect every time I run the compiler, I'm going to get an error as I'm writing code. Okay, let's do the same thing for transfers. And this should be very similar. So this is going to be a result of nil or create transfer result. And again, just typing all these different uses of the word result, Rust result, some tiger beetle result. Just semantic satiation or saturation. Semantic saturation, I think, is a term for that, when it's just like slightly different meanings just bombarding you. Create transfer OK, we're not going to need, and I think the pattern down here is going to be exactly the same. or this is just an OK of nothing, and this is just an error. Really, this is quite elegant. Look at that. That is easy peasy. Let's check that. Still building. I'm so skeptical. Let's make a syntax error. Okay. Okay, still building. Great. Everything's working. Now look up account. Okay, let's do the same thing. This one's going to be different. This is going to be a result of account, or question here is whether we just use nil here or we create a new error to represent not found. Like we could create an error that means not found, and I think we probably do need to do that. But to start with, we can use a nil error, and that will work. And as a rule, you don't want to use nil as an error type in Rust, because error types, this will work here. It'll type check as an error type, but nil doesn't implement the error trait, or at least traditionally has not implemented the error trait. Maybe it does these days. I would hope not. And so if you use nil in your error types, it won't be compatible with things like the question mark operator. So as a rule, you don't want to just use nil to represent an error. But to start with, I think we'll be able to put a nil there. So we're going to do it. And then we'll come back later and create another error type. Yeah, let's do that. Now here, these are going to be different. This is going to be I think this is probably going to be okay like that wait, no. Again, so this is the empty case. If a lookup account fails, it's not found. So that's going to be an error of that. And if the lookup succeeds, it's found. So that'll be an OK wrapped around an account. So I think it's basically just the opposite of what we did for the other request. And let's see if that checks. And it does. Wow, this is going so much easier than I expected. All right, let's do the same thing for transfers. And here, look up transfer OK is going to be a result of transfer or nil, aka not found. And the empty case is going to be an error not found, and the non-empty case is going to be OK of a transfer. Let's go check that. Suspiciously easy. Let's go run real quick and just make sure everything is still running. And all looks right. Okay, let's checkpoint that work. And so that immediately better. We've gotten rid of 4 structs, and our API is more idiomatic now. Get account transfers. Gotcha, okay. Yeah, more idiomatic now. At the one expense of these type signatures being quite a mouthful, these method signatures. But we still have this nil as an error, and I don't want to do that. So what I want to do is define a new error type just for our use here. And I'm going to use the this error crate to help with it. In general, in Rust, you have, so Rust errors are pretty expressive, but implementing all the traits needed correctly to define a new error type is pretty cumbersome, and almost nobody implements errors by hand. They almost always use some kind of macro to help them implement error types. And as a kind of baseline rule of thumb, you're either going to use the anyhow crate to create errors, or you're going to use the this error crate to create errors, both created by the same guy, dTolnay. His name on a crate is a mark of quality. A lot of his crates are core parts of the Rust ecosystem. And right now we've been using anyhow for our errors. And as we polish the interface, we have to get rid of those because in general, libraries shouldn't be returning anyhow errors. Anyhow errors are existential errors. They just like, here's an error. It's a, can't really introspect what it is, at least not easily. It just says some error happened. Whereas this error crate helps you define very strongly typed errors that say exactly what happened. And for a library, that's usually what you want. Like applications, you can kind of fudge it with anyhow, especially for prototyping. I'm almost always using anyhow for all purposes. Like if a library gets to the point that it needs to go to production, then I use this error. It's significantly easier to use anyhow than to use this error or other more precise error handling types. But let's go see if I have this already as part of our Rust crate. So this is our manifest, and you can see I already anticipated this at some point. We need to use this error. And I may need to reference the docs for this error, but I'm not entirely sure. Let's go to lib. Now the hard part is figuring out where to put this error. I am feeling like it is not a super important part of the API. I'm going to put it down here with this reserved helper struct. I'm going to say pub struct not found. And that is the whole error. And I'm hoping that this error supports this struct syntax. I'm going to say derive error. I'm going to say derive this error. So I don't have to import anything from this error. This is the only place I'm using this error right now. And we'll just see what the compiler says about this. This is certainly not enough information yet to actually create an error. I'm going to have some other annotations here. Well, let's just see what the compiler says. Okay, does not implement display. And this error, the this error macro will help us implement display if we give it the right attributes. Debug we haven't done, so I can put derive debug. And okay, so the only thing we're missing here is display. And I'm just gonna guess. I want to try to just guess the attribute. So if we put the right attribute in the right place, then this error will derive display for us. I want to say, let's look at the docs. All right, let's go back to the web. And I got to remember to go back to the terminal later. Don't let me forget. Where is our web docs? This error. Let's look through the examples. Probably something like this. And we don't have a variant to put it on, so hopefully if we just tag the struct, this will work. Almost every error type in Rust is an enum, but this one is just a standalone unit struct. If we say error, not found. Now I usually use lowercase error messages. I am not entirely sure why, it's just a habit. You could do that as well. And here we're not really able to say like what is not found because don't have enough data to say like account not found, transfer not found. What did I forget? Future highway. Oh, that builds. Not found. I think this is kind of good enough. It doesn't really matter, this error message probably. We probably want EQ, partial EQ, etc. All the standard stuff, because if we think about how people are going to use this, they're probably going to want to be comparing it. So I'm going to say derive EQ, partial EQ, ORed, partial. ORed doesn't make sense because there's only a single value. Partial EQ will make sense for comparing it when it's inside of a, well, I'm not sure we need the EQ on that yet. We'll see later. put a to-do up here, actually. Does not found need EQ. Partial EQ. Forgot to... Future Highway. Thank you. You even like told me immediately after I told you to remind me, and I didn't understand what you were talking about. Chat, I'm sorry, I forgot to switch back to the screen. This is my code. So here we've derived... Someday I will get the muscle memory to remember to switch back to the code screen. Thanks, Future Highway. Thanks, Future Highway. So many times I've done that. Thanks, Tired Beaver. All right, so all we did here while you weren't seeing my screen was I put this little error on not found, and then I chit-chatted a bit about whether to capitalize this in. Let's check that. Everything works. But we haven't actually put this into our methods. So let's go find those methods that we were returning a nil error type. Where are those? Somewhere up here. Not that one. This one. Submit lookup accounts. This is either a result or a not found. And actually, with that not found right there in the signature, all of a sudden this method signature looks much clearer. Like a reader is going to be like, well, I totally get what it means to have an error on the account lookup result. It means the account's not found. So solid improvement there, I think. And I think those are the only two places we use this. Let's do a check. And yeah, need to make the code changes here. This is going to be an OK not found. And immediately I'm seeing there's some other traits we're going to need to derive because this has to be copyable and or clonable. And this is an error not found. And let's just let the compiler tell us that. Yep, totally. You can see, oh, there's something else here. But this first one's saying, yeah, not found needs to be copied. So let's go back to, I'm just wondering if I screwed something up here. Create transfers. Oh yeah, I did. This is incorrect. The not found belongs down here with lookup transfers. Okay, let's go look struct not found. This also needs to be copy clone. We need it to be copy, but if a type is copy, the compiler requires it to also be clone. Okay, that all checks. Let's run it and just make sure everything still does something. Great. Okay, so suddenly this API is starting to look very pretty. At some point, when I'm developing a REST API, I would actually kind of like start looking at it from a docs perspective. Like I would say like a cargo doc and start reading the docs and making sure the docs look beautiful, because that's really where the rubber hits the road when it comes to beautiful APIs. They have to be documented beautifully. But we're not really there yet. We still got some flaws in this API that we need to iron out. But I am like feeling really good about the cleanliness of this code. Everything is looking very lovely. Obvious thing here is these flags, these bit flags are still a mess. And you know what? I did not put a write some API docs. For our initial MVP, I don't think we have to have comprehensive API docs, but especially for like if I'm publishing a Rust crate, I want the API docs to be unimpeachable. Like the API docs should be beautiful. Really explain everything about how to use the crate. And we'll get there, but I don't think for the MVP we're going to really create beautiful docs yet, because we don't really know everything we need to know at the MVP. We're going to get a lot of review probably during the first PR, and then maybe some feedback from users. And we'll write some cursory docs, but we're not going to go all in and write examples and make sure everything is fully covered in the first iteration of this crate. So bit fields, error types, is that? No, there's still a little more to do with error types, I think. This we've done, that is done. Is there more to do with the error types? I'm not sure. So we have these results. These are just copied from the Tiger Beetle results. And there might not be anything to do here. One thing we can do that I would really like to show is how to write the unit tests in a way that ensures that this enum is exactly the same as the C enum and allow us to remove this unknown variant here. I think I'll remember to do that just from the test harness PR or test harness to do. And I'm really feeling like maybe we are about done for today. The other remaining things here are pretty chunky, but I think this better error types is done too. I don't really see any more to do with the error types. Bit fields, destructor messiness, test harness, API docs. Each one of those feels like a nice single unit of work to do on a stream. All right, I'm going to commit this work. I'm going to push. Okay, chat, we're going to wrap up. So everything's really flowing now at this point. You know, we had several weeks where things were a mess and we didn't know what we were doing, but now we're kind of home free for the MVP. So we got those 4 things on our checklist. Once we get those done, we'll probably be ready to submit a PR, get a first round of review, and all the code will be in tree. And after that, there's, a whole long tail of production issues that we got to address here, like especially performance and maybe some higher level niceties around the API. But this fundamental baseline API is getting really nice. So my name is Brian Burson on GitHub, BRSON. You can find my socials on my GitHub page. I don't do this stream on a regular schedule, but I am doing it pretty frequently, and I usually announce 10 minutes ahead of time on the Tiger Beetle Slack and on my Mastodon account before I'm going to stream. And I'm getting pretty close to the point where we're going to upload all these to a playlist on the Tiger Beetle YouTube. Just waiting for the last few bits of work to get done there. And I'll probably be back in, sometime this weekend to knock out a few more of these to-dos. Again, I really appreciate all the chatters who come and hang out and, help me work through some of these bugs and, just have been following along and paying attention. I really appreciate that. It's really encouraging. So I'll see you all next time. Thanks a whole lot.